I'm late to my own party. How's it going, everybody? Welcome to the live stream going over homework number 2 over on probability. Hi, Hannah. Sorry I'm late. I tried to use a new computer or a different computer today on a Mac, which is much different than using it on the PC, and everything was all set up. But then Jolie decided to come use it because she liked working on the smartboard software, so everything was closed. I'm going to close those blinds behind me. Okay, so let's go over the lesson that you did last night, the one that you watched, which was number 2. Now I have to reset everything back up. Okay, here, that's the homework. Let me open the lesson. So there's a delay, so if you have any questions, start asking and typing them now. So this way, once everything's all opened up, we can start going over any of those questions. Hopefully you found that a lot of this stuff was kind of straightforward. Basically what they're just kind of setting up for you is showing you how to set up sets. We're going to start working with sets and what those sets are. So a set is just basically a collection of whatever you want it to be or whatever it is the question is making it to be. And then a subset would be anything that you could pull out from that set. Okay? And then you have a complement of a set is basically whatever is not in that set. Okay? Exercise 6, 7, and 8. Yeah, those ones we add, so then we'll be able to go over those ones now. So he kind of gave you the general. If you try to do 6, 7, 8, awesome. If not, we're going to go over them now. And this way we can be all caught up, go over homework, and be done. I don't know about you guys, but I'm not really liking this whole quarantine thing with the kids. This definitely reinforces me never wanting to teach in elementary school. Trying to do preschool, kindergarten, and second grade, math, science, English. What else do we have? We have Spanish, art class, music class, gym class. It's just way too much to do every single day. So, yeah. Hopefully sooner rather than later we'll be able to get back to school because I don't like this. Definitely not for me. So let's just jump right over to 6, 7, and 8 and see if you were able to do it or if you have any questions. Okay. So here we go. Let's start with 6. So 6 says a lot of times when they have U, it's talking about the universal set. Okay. So this is everybody you can have. So you can have 1, 2, 3, 4, 5, 6, 7, 8. And then they created set B, which is 2, 3, 5, and 6. And they said set B is a subset of set U. What is the complement of set B? So if B has 2, 3, 5, and 6, if I get rid of 2, I get rid of 3, I get rid of 5, I get rid of 6, what's left? Well, what's left is this complement, or the answer. And that would be 1, 4, 7, and 8. And that's it. Okay, so that's how you find complement of anything. Okay, and then 7 and 8 kind of piggybacked off of that, but it was a little bit different. So it says, in a survey of 400 teenage shoppers at a large mall. Okay, so if I'm going to make a box here, basically 400, those are all of the students that they talked to. Whatever that is, said that they shopped, there was 240 people shopping there. So right here, we would put 240, okay? I'm not going to put that inside, and you'll see why in a second. Okay, then they said there were 210 people shopped at Bongo Republic. So then you have 210 there. and then there was 90 that said that they shopped at both stores. So now the reason I didn't just go ahead and write this 210, well, if you look at the numbers, they already go over 400. So that's how you know that, something's not right totally here. And that's because some of this 90 belongs to this 210, and some of this 90 belongs to that 240. So basically what you're going to do is you're going to take those parts out, and then what's left is going to go in here. So if you do 210 minus 90, that's going to be 120. 240 minus 90, that's going to be 150. Okay, my notes are somewhere, so I hope my numbers are right. And that kind of shows you exactly how many shoppers only were here and how many of the shoppers were only here, and then kind of mixing between is that 90. So then the question says, how many of the teenager shoppers surveyed did not shop at either store? So basically, here are your numbers here. So basically, you have your 150 and your 120 and your 90. Those are the three. And if you add those up, you have 360. So there was a total of 400. So then how many are left? And that's going to be 40. So that's how you know how many shoppers were not left at that store there. Okay, so now kind of keep this idea in mind when we go down to the next one. So again, just to kind of show you again where these numbers came from if you missed it, 400 is your total. Okay, the 90 is what shops at both of the stores. So when they told you that 210 were shopping at Bongo Republic, that doesn't mean that they only shopped at Bongo Republic. That means that some of them of that 210 could have also been shopping at that other store. So what you do is you subtract the intersection number, and then this shows you exactly how many are only at Bongo. This one shows you how many are only at this store that I have no idea what it's called. And then that's kind of where those numbers came from. So now if I'm jumping right down over here to number 8, look at the difference and look at how they kind of put that into the Venn diagram. So this is how you kind of know that how many students are taking a foreign language. Well, they're only inside the foreign language, so there are 23 that only take foreign language, and there are 14 that take both. Okay, so then you gotta kind of watch where you're going there to be able to fill these out. Okay, so right here, that's going to be how many students. So you're going to take the 23 that are only in foreign language, and then the 14 that are in both, and then that's going to be 37. How many students play sports? That's the 14 and the 24. Okay, how many students do both? Well, that's the 14. How many students do not take a foreign language and who do not take a foreign language and do not play a sport? So basically, you're just looking at these two numbers. Okay. Okay, these three numbers, because this is only foreign, this is both, and this is 10. Okay, so if you add up all of those numbers there and subtract from 50, let me get my notes here so I'm not throwing people off too much. Okay, so where am I? Okay, where are we going? Okay, so there, got that there. Totally lost on this. How many students do not take a so we're taking out these people here, because there, and then you're left with this here. So you take again that 23, that 14, and that 10, you're going to be at 47. So how many are left? Well, if there's a total, they said here 50, that 50 minus 47, and there's going to be 3 people that are in neither. And then the last one, if a student is randomly chosen from the set, what is the probability that they play a sport but do not take a foreign language? So then that's going to be your 10 out of your 50 or your 1 out of 5. Okay, So that kind of goes through those last 3 exercises that you were supposed to do or tried last night. And then we took a look at our homework. Okay. All right, so here we go. Consider the experiment of picking one of the 12 months at random. So you guys know 12, January, February, March, April, May, June, July, August, September, October, November, December. Write down the sample space for this experiment. What is the value? So we know that, well, there are 12. And I just told you what they were. January, February, March, April, May, June, July, August, September, October, November, December. Okay? So August. So there are my 12. So let E be the event or the set of picking a month that begins with the letter J. So we kind of looked at that yesterday, and J has 1, 2, 3. Okay? So write out the elements. So they want you to write down January, June, and July. So there are 3. Then it says on the next part, well, what is the probability of picking? Okay, this is what it says. The probability of event E, and this is what event E was. How many elements are there? 3. What's our total? 12. That could be an answer if you simplify it. 1/4. That could be an answer. Sometimes they like to write it as a decimal. That could be an answer. If you multiply that by 100, okay, that could be an answer. So it's a 25% chance, okay, which is something probably you're more familiar with. They usually don't say, well, the odds that it's a 1/4 chance. Okay, and here is kind of the complement part. What is the probability of picking a month that does not start with the letter J? So this one's not too bad because you can just see them and copy them, but there's a shortcut to it. If I'm looking at it, well, if you're not a J, it's everybody that's left, and there's 1, 2, 3, 4, 5, 6, 7, 8, and 9 months left. So it's 9 out of the 12, okay? Or 3 out of the 4, or 0.75, or 75%, all the same thing. But, okay, sometimes it's not going to be staring you in the face where you might actually have to do the math, which is not too bad. Remember, to have probability, if you're always going to win something, you're never going to lose, the probability is 1. Okay, that means you're always going to get it. That's like having in this one, what's the odds of me picking a month out? Well, there's 12 months, and I can pick any of them. It's 12 over 12, it's 1. So that's why probability only goes up to 1. So if I know that 9 out of 12 or 3 over 4 is the probability, here's how you can get that with any complement, not just this one. What you could do is you take whatever the event that you know and you just subtract it from 1. So it's just 1 minus 1/4. Or even more general than that is basically you just do 4 over 4, whatever this denominator is. So if this was a 6, I would do 6 over 6. 4 minus 1 is 3, and the denominator stays the same. Or just subtract those 2 numbers there. It'll always work like that. Okay, that's how you find the complement of the set. Okay, so remember, if you have any questions, I can see them on the side, so just go ahead, or if you need me to clarify something, I can do that too. All right, next one. Consider the set A of all integers 1 to 10 inclusive. So that's a vocabulary word you want to get used to. That means you want to include those numbers. 1 to 10 means I want 1, I want 10. Set B, okay, so let's start with set A. They just said that the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then they want set B. Set B is a subset of A, and it's assigned as the integers less than 5. So who is less than 5? 1, 2, 3, 4. okay? Then it says C is the complement of B. Well, again, to do complement, just take everyone who is left. So 1, 2, 3, 4, you don't want, so who's left? 5, 6, 7, 8, and 9. And there you go. That's how you do number 2. Okay, 3. A and B are complements. Then which of the following is true about the probability of B based on the probability of A? Okay, so try not to overthink that based on the words. So A and B are complements. If you have one probability, to get his complement, you just do 1 minus that. So in this one, I want to know the probability of B. So to take his, that I just do 1 minus, well, the probability of A. That's going to be choice 2. Okay. 4, same situation. A fair coin is flipped 3 times. The probability it will land heads up all 3 times is 1 out of 8. Which of the following is the probability that when the coin is flipped 3 times, at least one tail will show? Okay. That's a complement question. So they're saying to get heads, 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 there's only one way in 8 chances. You can get heads, tails, heads, heads, tails, tails. Everyone else will have a tails in it. 1 minus 1 over 8, or 8 over 8, or 8 minus 1, 7 over 8. There's your answer there. Okay, so then that's another complement question. All right, and you could always draw out a tree diagram on that one. Just do heads, tails, and then break it up again. Heads, tails, break it up again. Heads, tails to each one of them, and you'll be able to count them, and there'll be 7 of them. Okay, and then the next one, or I'll simplify to 7 out of the 8. A 4-sided die in the shape of a tetrahedron is rolled twice, and the number rolled is recorded each time. Okay, so then draw a tree diagram to show the sample space. So if we want to show that sample space, okay, tree diagram, well, we roll it the first roll. What could we get? We could get a 1, we can get a 2, we can get a 3, or you can get a 4. Now let's roll it a second time. What can you get now? You can get a 1, a 2, a 3, or a 4. 1, 2, 3, 4. 1, 2, 3. This is getting messy. 4. 1, 2, 3, 4. Hopefully yours is going to be much neater than this, because this is a disaster. Now, question says, okay, so I wrote out, showing this is my sample space, how many elements are in the set? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay? That is exactly how many different ways that you can get, okay? B, I'm good, just teaching math here. B, let E be the event of rolling 2 numbers that have an odd product. So product means to multiply, so when you multiply the 2 numbers, and they want to know, list them as an ordered pair. So if you could just roll them. Well, 1 times 1, that's odd, so 1 and 1. 1 times 2, 1 times 3. Okay, 1 times 4. Okay, those are the ones that were odd from rolling a 1. 2 times 1, 2 times 2, 2 times 3, 2 times 4, all even. 3 times 1, 3 times 2, 3 times 3, and 3 times 4. So there you go. 4 times 1, 2, 3, and 4 are all even. So these are all of the elements that would have a product of being odd. Okay, so that's how you do that one. C, what is the probability that 2 rolled numbers have a product that is odd? So now they're asking about that probability. So the question is, how many were odd? We got that from B, there were 4. And how many was the total? And there were 16. So you can write that as 4 out of 16. From here you can simplify, use your calculator, 1 out of 4, it could be 0.25, it could be 25%, okay, and there you go. And then it says, what is the probability that the two whole numbers will have a product that is even? Well, then if you have a 1 in 4 chance of being odd, then every other chance has to be even because you're either odd or you're even. So if it's a 1 in 4, then 4 minus 1 is 3. So 3 out of 4. And that's your answer. Okay. How'd you get the 4? The 4, I didn't get the 4. Okay. Oh, wait. Question. There's going to be a delay. All right. See you later, Abner. Are you talking about this 4? If you're talking about this 4, then I got that from here. Okay, so what is the probability that the two rolled numbers have a product that is odd? Okay, E is the event of rolling two numbers that have odd. So here are all of the ways going down my tree that I could be odd. And how many were there? There was 1, 2, 3, 4. So that is the 4. And then the 16 is the total or the sample space. So the 16 came from here and the 4 came from there. And then the other one, okay, even if you use 4 over 16, that would be 12 over 16. It's still all going to give you the 3 over 4. So even if you did not simplify, you can still get the same answer. That would be simplified to be 3 over 4. Okay, so I hope that one helped there. Okay, 6. Alright, so consider the set of all integers from 1 to 10 to be our sample space. So in this box here is 1 to 10. Okay, so the sample space is 1 through 10. So let's now see where all of the numbers go. A be the set of all integers in S that are even. So here we'd get 2, 4, 6, 8, and 10. Let B be the set of all integers in S that are multiples of 3, which would be 3, 6, and 9. Fill in the circles of the Venn diagram with the elements from S. If an element lies in both sets, place it in the overlapping region. So after we fill it in, I can go back now and look. Well, they both have a 6, so I can take the 6 out, and then I can take that 6 that they both shared, and then put that in the center. So 2, 4, 8, and 10 belong in A. 6 is in both. 3 and 9 belong in B. So who's left that's going to be out here? 1, 5, 6, 7, and that's it. 1, 5, and 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 numbers. So there they all are. So these guys belong to no one. They're just in my sample space. 2, 4, 8, and 10. 6 is shared, and 3 and 9 is in B. So then now, who was in A? Well, A got 2, 4, 6, 8, and 10. In B was 3, 6, and 9. There is your two sets. And now 8 is saying, why is the following equation not true? So what they're saying is, if you take A and you take B and add them up. Well, let's show it. The sample space is 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. In A was 2, 4, 6, 8, 10. In B was 3, 6, and 9. So prove that this is not true. 2's cancel. 3's cancel. 4, 6, 8, 10, got 6, got 9. Well, there's nothing left over here, and over here I have 1, 5, and 7. So that's why it cannot be true. So explain, well, the reason is because the elements in A and the elements in B do not make up the entire sample space of the numbers 1 through 10. So either the explanation or showing the work like I did there all work. And that concludes 12-2. Okay, so I'll wait a couple minutes. If anybody has any more questions, we can go through that. And then again, tonight you'll try to go through 12-3, which now starts to go into, it's very similar, adding probabilities to what we did today. How is everybody else out there? Everybody good? The delay is like a good 30 seconds behind. Yeah, I'm not really bored because I have 3 kids to really occupy my time, and the amount of work that they have to do is insane. But at least it's nice. See, don't take advantage of school. People always say school's so boring or school's so this, but the alternative is staying home and doing absolutely nothing. See, when you guys have names like GD Super Ducky or DeSosa, I have no idea who you are. Hi, Eliza, I know you. Hannah, I know you. But that's pretty much it. Young King, I have no idea who Young King is. Nor would I even be able to guess who Young King would be in my class. Thanks, Miss Holden. Miss Holden, were you here the whole time? I wonder if there's a way to see. No, don't put my. And I was late today. I tried it on the Mac this morning. It worked. Didn't work before. Maybe when I do the next lesson, I'll try it. All right, well, I guess I'll see you tomorrow. If there are no final questions, then we will do the same thing tomorrow, 12-3. www.cimath.com has all of the worksheets on it. I also threw up on there, if you do not have your calculator, which you really don't need right now, there is a spot that you could download it online. It doesn't work for Macs. I'm still looking for one for a Mac. And everyone have a good night. Stay quarantined. Stay away from